The National Electrical Code, or NEC, dictates that for a 48 amps Underwriters Laboratories, or all listed power distribution unit, or PDU, the maximum breaker size is 50 amps. This is because the UL listing certifies the PDU capability to safely manage a continuous load of 48 amps. Surpassing this load could potentially harm the PDU or lead to overheating, thus posing a fire risk. A recommendation to size the circuit at 60 amps does not align with the NEC standards. Even though the PDU might endure a greater load briefly, its design isn't meant for sustained usage at that level. The NEC constitutes a collection of safety regulations overseeing the setup and use of electrical devices in the United States. Adhering to these standards is crucial for ensuring the security of the electrical system. In the given scenario, the circuit should be sized at 50 amps, and a PDU with a UL listing for a continuous load of 48 amps should be utilized. When dealing with electrical installations, especially concerning power distribution units and circuit breakers, adherence to the National Electrical Code is paramount. The NEC provides specific guidelines to ensure safety and prevent potential hazards. One critical aspect is the proper sizing of circuit breakers for PDU, and this is directly related to the UL listing of the PDU itself. The UL listing indicates that a device has been tested and certified to meet specific safety standards. In the case of a PDU, the UL listing specifies the maximum continuous load that the PDU can safely handle. This continuous load is the amperage that the PDU can reliably supply over an extended period without overheating or posing a risk of failure. When selecting a circuit breaker for a PDU, it's essential to consider the PDU UL listed continuous current rating. The NEC mandates that the circuit breaker should be sized no larger than the ampacity of the conductors supplying the PDU and should also be suitable for the specific application. In this context, if a PDU is UL listed for a continuous load of 48 amps, the maximum allowable circuit breaker size is typically 50 amps. This seemingly small difference is crucial for several reasons. Firstly, it provides a safety margin to prevent nuisance tripping of the circuit breaker. Circuit breakers are designed to trip when the current exceeds their rated value, but they can also trip due to temporary surges or overloads. By sizing the breaker slightly higher than the continuous load, you can avoid unnecessary interruptions of power. Secondly, it protects the PDU from being overloaded. Even though PDU might be able to handle a slightly high current for a short period, continuously exceeding its rated load can lead to overheating and eventual failure. This can result in costly downtime and potential damage to equipment connected to the PDU. The NEC provides specific tables and guidelines for determining the appropriate conductor size and overcurrent protection for electrical circuits. These tables take into account factors such as the conductor material, insulation type, ambient temperature, and the type of load being served. It's important to consult these tables and follow the NEC guidelines to ensure that your electrical installation is safe and compliant. In addition to the NEC, local electrical codes and regulations may also apply. These local codes may have additional requirements or restrictions that you need to consider. It's always a good idea to consult with a qualified electrician or electrical inspector to ensure that your electrical installation meets all applicable codes and regulations. Ignoring these codes can lead to fines, penalties, and even legal liability. When installing PDU and server racks, it's also important to consider the overall power distribution strategy. You need to ensure that the total load on each circuit is within the capacity of the circuit breaker and the conductors. It's also a good idea to provide redundant power supplies to critical equipment to minimize the risk of downtime in case of a power failure. Regular maintenance and inspection of PDU and circuit breakers are also essential for ensuring their continued safe and reliable operation. This includes checking for loose connections, damaged wiring, and signs of overheating. Any problems should be addressed promptly to prevent potential hazards. Thirdly, ensure compliance with manufacturer specifications. While NEC guidelines provide a general framework, always refer to the PDU manufacturer's specifications for specific recommendations regarding circuit breaker sizing and other installation requirements. Manufacturer specifications may provide additional details or limitations that are not explicitly covered by the NEC. Fourthly, consider deterring factors. In certain situations, such as high ambient temperatures or enclosed spaces, it may be necessary to deter the ampacity of conductors and circuit breakers. Deterring involves reducing the allowable current carrying capacity to account for these factors. The NEC provides guidelines for deterring conductors and circuit breakers based on specific conditions. Fifthly, understand continuous versus non-continuous loads. The NEC defines a continuous load as a load that is expected to operate for 3 hours or more. For continuous loads, the overcurrent protection device, such as a circuit breaker, must be rated at not less than 125% of the continuous load. This is to prevent nuisance tripping due to prolonged operation at or near the breaker's rated capacity. Non-continuous loads, on the other hand, are loads that are not expected to operate for 3 hours or more. For non-continuous loads, the overcurrent protection device can be sized closer to the actual load current. Sixthly, consider future expansion. When designing an electrical system, it's important to consider potential future expansion. You may need to add more equipment or increase the power demand in the future. To accommodate this, it's a good idea to size the circuit breakers and conductors slightly larger than the current load requirement. This will provide some headroom for future growth without having to replace the entire electrical system. Seventh, proper labeling. Clearly label all circuit breakers and PDU to indicate their function and the equipment they serve. This will make it easier to identify and troubleshoot problems in the future. Labeling should be durable and easy to read. Eighth, grounding. Ensure that all PDU and equipment are properly grounded to provide a safe path for fault current. Grounding helps to prevent electrical shock hazards and equipment damage. The NEC provides specific requirements for grounding electrical systems. 9. Surge protection. Consider installing surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage spikes and surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD can help to divert these surges away from equipment and prevent damage. 10th, documentation. Maintain accurate documentation of all electrical installations, including circuit breaker schedules, wiring diagrams, and equipment specifications. This documentation will be helpful for troubleshooting, maintenance, and future modifications. It's also a good idea to keep records of all inspections and tests performed on the electrical system. The NEC serves as a cornerstone for electrical safety, offering a comprehensive set of standards that govern electrical installations. Its primary goal is to protect people and property from hazards that can arise from the use of electricity. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. These updates reflect the evolving landscape of electrical systems and the ongoing effort to enhance safety. Adherence to the NEC is not only a matter of compliance, but also a fundamental responsibility for anyone involved in electrical work. By following the NEC guidelines, electricians, engineers, and installers can ensure that electrical systems are designed, installed, and maintained in a safe and reliable manner. This protects not only the individuals who work with electricity, but also the occupants of buildings and the general public. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for various types of electrical systems, such as residential, commercial, and industrial installations. The NEC also addresses specific hazards such as arc flash, electric shock, and fire. One of the key principles of the NEC is the concept of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. When the current exceeds the rated capacity of the circuit, the overcurrent protection device will trip or blow, interrupting the flow of electricity and preventing damage to equipment and wiring. The NEC specifies the types and sizes of overcurrent protection devices that must be used in different applications. It also provides guidelines for selecting the appropriate overcurrent protection device based on the characteristics of the circuit and the equipment being protected. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source. This helps to quickly trip over current protection devices in the event of a ground fault, minimizing the risk of electric shock and equipment damage. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metallic equipment. In addition to the technical requirements, the NEC also emphasizes the importance of proper training and qualification for electrical workers. The only qualified individual should perform electrical work, and they should have the necessary knowledge and skills to do the job safely. The NEC also encourages ongoing education and training to keep electrical workers up to date on the latest codes and technologies. The NEC is not a static document, but rather a living code that is constantly evolving to meet the changing needs of the electrical industry. The NEC development process involves a wide range of stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and safety experts. These stakeholders work together to identify areas where the NEC can be improved and to develop provisions that enhance electrical safety. The NEC is adopted by many states and local jurisdictions as the basis for their electrical codes. However, some jurisdictions may make modifications to the NEC to address local conditions or specific safety concerns. It's important to be aware of the electrical codes that are in effect in your area and to comply with all applicable requirements. The NEC is a valuable resource for anyone involved in electrical work. It provides a comprehensive set of standards and guidelines that can help to ensure the safety and reliability of electrical systems. By following the NEC, you can protect yourself, your colleagues, and the public from the hazards of electricity. Regular inspection and testing of electrical systems are crucial for identifying potential problems before they lead to safety hazards. Electrical inspection should be performed by qualified inspectors who are trained to identify code violations and other safety issues. Electrical testing should be performed using calibrated test equipment to verify the proper functioning of electrical components and systems. The results of inspections and tests should be documented, and any necessary repairs or upgrades should be performed promptly. The NEC also provides guidance on the installation and use of electrical equipment in special occupancies such as hazardous locations, healthcare facilities, and swimming pools. These special occupancies have unique electrical safety requirements that must be carefully considered. For example, hazardous locations, such as areas where flammable liquids or gases are present, require the use of explosion-proof equipment and wiring methods. Healthcare facilities require special grounding and wiring systems to protect patients from electric shock. Swimming pools require ground fault circuit interrupters, or GFCIs, to protect swimmers from electric shock hazards. The NEC is a complex and comprehensive document, but it is essential for anyone involved in electrical work. By understanding and following the NEC guidelines, you can help to ensure the safety and reliability of electrical systems and protect people and property from the hazards of electricity.